Welcome back to the Arduino setup videos. This is the second video, and the way we name these videos ARD for Arduino, 02 for the second video. In the first video, and if you have not watched it, I recommend to watch it. We're going to assume you know all the material from there. It kind of walked you everybody through what is the board, what is used, how to program it, how to upload the information, how to connect it, and that kind of stuff. In this video, we're going to focus on digital read and write. So let's talk about a couple of items we're going to need, because if you're going to read and write from outside, we have a way of presenting the information so you know something got written or not. One of the easiest way to display that something is changing in the Arduino is LED and resistor. On video 1, we used the built-in LED, which was on pin number 13. In this case, we're going to use some of the other pins. Okay, so the resistors are always, from a symbol point of view, they're always represented as basically usually 3 wrinkles out, and they're referred to usually as an R. We have one there called, which is 1000 ohm, and sometimes we just simply refer to it as 1K. Same thing. That means it's 1000 ohms, and if you don't know Ohm's law or you're not very familiar with electrical circuit, I would encourage you to take a look at the FEC series of videos, probably starting as FEC1, and those are all as part of the YouTube ENGR CS channel. But anyway, so that's all you need to know for now. As a resistor, it looks like, symbolically we show it like this. And then the other component you have to be aware of is an LED. When you usually show LEDs like this. And LEDs basically is light emitting diodes. So when you run current through them, this current, electrons running through the diode will cause it to light up. You can get it any color you like. All of these we're going to use what we call a true hole type bigger devices, so I can handle it with my hand. All of these devices come in surface mount, much smaller if you're trying to go to production. But for now, it's much easier to get the through hole version, because then you can play with them. Okay. Now that we've talked about these two, let's go take a look at it. Before we go, if you notice, the resistor doesn't have direction. You can send current either direction, it won't make much of a difference. LEDs have a direction, so you got to go from the positive side to the negative side. So you have to remember where the negative side is, and always think about the negative side being the short leg and the positive side being the long leg, at least the ones that have leg. That doesn't apply to surface mount. Okay, now let's go take a look at these pieces and see what they look like first. So here's an LED. You can see it's got a short leg and a long leg, so you want the positive side to be long leg, short leg. Also, if you look at it on the short leg side, the body of the LED, I'm not sure if you're going to be able to see it here, the body of the LED has a flat side on the negative side, indicating that's the negative side. Okay, so that's that. And then the resistor, if you look at this particular resistor, you'll see it's got band. It's kind of hard to see it here, but this one is brown, black, red. All of those have meanings, and this basically, brown says 1, black says 0, and red says multiplied by 100. And the gold says this tolerance is 5%. Okay, so now we have these two components. And then when we want to build circuit, it's really nice to be able to connect things and disconnect them without having to solder things or jumper things. So this board is very useful if you've not seen it before. It's very useful to have this board. This is called a Protoboard. All this row is completely connected to each other from one end to the other end. Blue is connected all together, but not to red. Same thing on the other side. And each of these 5 holes are connected to each other. So column 1 is connected, is 5 to each other, but not to column 2. But column 2, all 5s are connected. Up here, the same way up here. So this is really kind of useful, because, for example, if I want to take this LED and I want to connect it to this resistor, all I have to do is put this pin in here and this one over here. So see what happens? I made the connection since underneath these 5 rows are connected to each other, then I've made a connection from here to here. Okay, so I don't have to twist them together or do any of that stuff. So all we're going to do now, if I put so the way this works, and I'm going to use my Arduino board to just kind of show you how things are going. This time we're working for digital, so only this row is what we use. Okay, so let me give you an example how this works. So for example, you see there's a, I don't know if I'll wait for it to zoom. See the ground pin? So I'm going to connect the ground pin to the negative side. This was the short end, resistor, short end of the LED. And then I'm going to take the long side of the LED. And if I plug that into a 5 volts, you see there's a 5 volt. I don't know if you can see it from there, from your screen, but this is a 5-volt pin. If I push it in, the light turns on. There's a light, and if I pull it out, the light goes out. So when I push it in, electricity is flowing through that and it's turning on. That's not very exciting. What I want to do is I want to be able to control this LED, turn it on and turn it off as I need it, or as I want to, just to show that I can control it from the, I'm going to put a pen in here so you can kind of see it. Okay. So now that we kind of figured out the hardware a little bit, let's go back in here. So what I just set up is I took the LED, connected the short side to a resistor, put it to ground. These are symbols for ground. This is for my 1000 ohms. And then I'm going to put my output from the Arduino into here to light it up. Or if I go high, because digital, if you go high, it will light up because you're going to have higher voltage so the current flows through here. If I go low, it's going to turn off. Okay, so that's good. That's basically the hardware I've set up to show that I can write into a pin of an Arduino from my computer. Okay, or actually program the Arduino to do it. All right, so one other thing I wanted to mention, just to be on the safe side, when we say digital, that basically means it only can go high, which is 5 volts, or also called 1, logic 1. Low is 0 volt to logic 0. So we use low and high to indicate that. That's the only thing. We don't have anything in the middle that we can set it to. It can either be high or low when you go digital. Later on, we talk about analog, which you can set it anywhere between 0 and 5 volts. And we'll talk about that in the next videos. Okay? So, and then finally in this video, we're going to talk about, okay, when I'm reading information, how would I display it on the screen? That comes later. Okay, so now let's go ahead and take a look at a piece of code I kind of wrote in here because it's a little easier to see up here and I can mess with it. And then we'll go look at it. We'll go do it on the Arduino. Just some principle of programming I just want to cover before we go too far. This /star, as we said before, is used for commands. Usually we use that if I've got a long line of things to write. All I do, I started with /star. Everything is going to be considered comment. The computer will ignore it. It's for the next human who reads your code, all the way till you get to */ and then that ends. So all of this is simply comments. Okay. Now, the next thing we have here, we don't have to do this. We can put 4 and 5 anywhere we want, but humans remember names much better than numbers, and sometimes we get confused between numbers. So this, all it does, anywhere I put this name, and you can make up any name you like. Usually we use capital letter. So we are creating a constant. Anytime I say pin I, 4 will be replaced. It's simply, I could have written 4 anywhere I say pin IO. And then pin O is pin, a 5 goes in there. So these are called define. These are constant defines, and they really don't take up any memory space or anything. They're just a way for us to not have to write 4 every time. So there are 2 advantages. One, don't forget which pin. 4 and 5 you can get confused, but input and output you don't get confused. And the other thing is, if tomorrow I want to have my same program, but I want it to be pin 6 and 7, I just come in and replace one place and everything changes. So it's very valuable. Those are constant. Once I set it, that's it. And then we have another thing we call an int, INT, which is stands for integer. Sometimes we want to have a variable so I can put different numbers in it. And right now you can name this Sam or John or whatever, but this I like to name it what it somewhat representative what's in it. In this case, I'm calling it int value equal to 0. And why am I saying is equal to 0? It's always a good idea when you declare a variable to initialize it so you have a consistent behavior in your program and you're not hoping that somebody else take care of it for you. Okay. Okay, next thing is this. You always, if you're programming Arduinos, you always have to have this void setup, bracket open and bracket close. Whatever you put in this bracket gets executed once at the start of the program, and that's it. It will not get executed again. Okay, so what did I put in there? I said, okay, make pin I, remember that was pin 4, make it an input. So that pin on the Arduino is expected to be input. Next one I said pin mode, pin out, output. So now I'm setting pin 5 is output. Now pin 5 is output, pin 4 is input. What does that mean? So let's go to the, and then the serial begin. I'm just initializing this thing and we'll find out what it does later on and would make more sense. I'm initializing the serial communication between the computer and the Arduino through the USB at 9600 baud. And then, so now pin 4 is an input, pin 5 is an output. If I want to, so this instruction, digital read, will read pin I, which is going to be either 0 or 1, 5 volt or 0, and it puts its value to int value. Great. If I want to write something to pin out, I just can either put a high or a low or an int value in here, but it's got to be either 1 or 0, high or low, and that goes to pin out and it's written out. And then the final thing is a serial print line with a value. What it does, it prints that on my monitor, so if I want to see what I'm reading in, that's a pretty useful thing to do. And finally, delay 1000. We already know that says delay 1000 millisecond. I've changed the number. It delays more or less depending on what number I change it to. Okay, great. So this is kind of the basis of instructions we're going to use to do all kinds of stuff. Now let's actually jump in and do some of this stuff. So we're going to bring the Arduino like you've done before, and we're going to copy some of this code in here. So we're going to have we define pin in as 4 and pin out as 5. We're going to declare a variable int. So far we haven't done anything, we're just setting things up. And then we are setting that pin 4 is an input, pin 5 is an output, and then we configuring the serial port. And it's a good idea. I don't know why they all end up all over the place, but it's a good idea to be somewhat systematic and have all your comments more or less indent in the same place. It makes it a lot easier to read your code. Okay, and one of the common ones is in the process somebody might delete this little squiggly bracket that closes the setup. If you do, you're going to get an error. Okay, and oops, I want to do that. So that was set up. That you do it once, you're done. Now what am I doing here? I basically, look what I'm doing. I'm basically digital write to pin out, that's pin 5, and then I am writing a high into it. I'm not doing that, so let's get rid of it. I'm writing a high or 1 into that, and I'm writing a low into pin out again. So what should happen? So pin out, which is pin 5, should go high, wait a second, go low, wait a second, and remember the loop keeps running. So it goes back up here, set it to high, wait a second, set it to low. So you should be blinking if everything works. Now let's go ahead and go to the camera and set it up. Now remember, pin 5 is what we're interested in. So what we're going to do, I'm going to bring this up so I can see it. So we're going to take pin 5. See pin 5 here? I'm going to put this in pin 5. Get my hand out of the way. So pin 5, I've got my wire. Oh, you can't see it. Okay, here we go. Oops. Put it in pin. No. That's in pin 5. If you can see it. I don't know if you can. Let me pull it out a little bit. So pin 5 is connected to orange, and if you look, the black is connected to ground. Okay. So what we're going to do, I'm going to put this down, and if you recall, ground goes to this resistor, and if you look at it, it's got a long leg and short leg. Short leg is the resistor, and I'm going to take the orange pin 5 and put it to the other side of the LED. So now when orange pin 5 goes high, this will light up. When this the only reason I have the resistor in here is to make sure that the current doesn't blow this one out, because if I directly connect it, this might have too much current, and I'm going to bend it so it's a little easier to see. And it's blinking. Okay. So now, remember, I must have compiled it and put it in there, but you want to make sure when you wrote your code, which is here, you have to hit it to compile it and put it up there, okay? So we're compiling. And compiling and put it up there. I have some issues with the scratch, when I'll take care of that in a little while. Okay. So so that's good. So now we have this thing set up. Oh, cannot find. So let's see. So once in a while, the system USB gets lost, and that was the issue with us. So if that happens to you, just unplug the USB and plug it back in, and the buffers will clean up, and you should be able to continue working. You shouldn't have to close Arduino to do that. Just unplug the USB and plug it back in and reset the board, and that should take care of it. But anyway, getting back to here, we have an input and output set, but we're only using it as output. And if you, and I think that you may have seen on the screen that the LED was blinking as you were as we ran the program, and now so as you can see, we're doing it 1 second at a time, and let's go take a look at it, and you'll see that it blinks every second. Of course, you can extend or shrink it by changing the delay time. So now we know that we can write to these pins. And by the way, you can literally use any of the 13 pins that are there. Typically, I would stay away from 0 and 1, because those are the transmit and receive used for communicating serially. And then the other one, 13, is used for the internal LED, but from 2 to 12 is completely free for you to use, okay? Now, we use it as an output. How can I use it as an input? Well, all you have to do, go back to the program. And when you look at the program, and if you go back to our notes that we started with, you notice that there is a digital read. So that's how you read. You basically say digital read, and you give them the pin number you want to read from, and you put the value in here. So this alone, this basically allows us to read this. I'm just going to copy it, put it in here so we can observe it. So let's go ahead and let it blink every second or so, and then we're going to read the value that is in pin 1, and that the pin I input, which is pin 4. And then what we're going to do, let's go ahead and use now we're going to get to use this instruction, which basically says print the information out for me. So I'm just going to grab this instruction, and I'm going to put it in my code. And so we'll go back and revisit this to see exactly what we are doing. So remember up here, I had the serial begin, which was configuring this thing. Now what I'm doing is down here, I'm saying, okay, now print whatever is in int val, okay? And so here, whatever is in int val is whatever was on pin 4, okay? Why do I do that? Well, if I read this thing and put it into this variable, how do I know it really read that information? By printing it out, oops, I deleted that thing. By printing it out using the serial, I can actually see it in the screen. So what I'm going to do is basically, remember pin 4 is the input now. So we're gonna compile this again. Hopefully everything goes well. Compiling, uploading, done. Now, so what I'm going to do, let's go to the camera and take a look at the camera. So I need to make a 1 and a 0, and simply what I'm going to do is just use the Arduino board itself. I'm going to plug this in pin 4. Let me see if you guys can see. Oops, well, fine, that's fine. We don't need the LED anymore. So we're going to take pin 4, and then anytime I put it to 0, ground, it should read 0. Anytime I put it to 5, it should read 1. Okay? So what I'm going to do, I'm going to go back here and take a look at it. So here is the code. I've already uploaded the code. The code is running right now, and I'm going to start looking at the values. So turn on the serial monitor, and serial monitor hopefully works. Oh, it's reading 1. Now I'm going to take that pin from 5 and I'm going to put it in ground, and you should start seeing 0. See that? Okay. So now that we've kind of accomplished that, let's go back and look at the code one more time. I'm going to close this. So this, by the way, there's also a plot that is available that you can use to plot the information if you don't want to see it. As a bunch of numbers coming down, you can plot. You can set it as a plot, and it graphs it for you. Okay, that's back to here. So now we have a code. We can define 4 and 5 or whatever other pin. We have an availability to set a pin to input and output. We have an ability to read from it. We have an ability to write from it, and then there are all kinds of commands like C. You can do if then else's, loops, and all of those. You can make decision. If 1 is coming in, turn the motor on. If 0 is coming out, turn the motor off. Much like I was turning the LED on and off, you can also, little motors, you can simply plug them in there and they will turn on and turn off accordingly. That brings us to the end of the digital read and write. The next video, what we're going to do is we're going to focus on analog read and write. What if I want that LED to get brighter and darker over time? Is there a way for me to do that? And that would be our next video.